Hello, this is Dr. Hanaa Assil, and this is the second part of the review questions on Modular Unit 1 of the IGCSE Chemistry Edexcel. I'm going to remind you again that these are the topics included in Unit 1 of the modular system. Remember that the IGCSE Chemistry Edexcel can now be linear or modular. So these are the topics included in the modular unit 1. States of matter, elements, mixtures, compounds, atomic structure, periodic table, chemical formula, equations, calculations, metals, reactivity series, extraction, uses of metals, acids, alkalis, titrations, salt preparations, energetics, crude oil, alkanes, and alkenes. The table shows the reactions of four metals, P, Q, R, and S, with water and with dilute hydrochloric acid. Now, we are required to deduce the order of reactivity of these metals. You should remember that the reactivity series includes the more reactive metals on top. Any metal more reactive than hydrogen would react with acid. And the very reactive metals react with cold water, while the less reactive metals would react slowly with cold water or react with steam. So, if we look at P, it says P does not react with water, does not react with acid. Anything less reactive than hydrogen would not react with water or with acid. So P is probably below hydrogen in the reactivity series. Now Q is very fast, very reactive, so it is probably somewhere on top of at the top of the reactivity series. Now R, no reaction with cold water. Remember, when he says water, he means cold water. Slow reaction with acid, that means it is above hydrogen but not very reactive. S has slow reaction with cold water, fast reaction with acid. So compared to R, it is probably more reactive than R. So in that case, the order starting from, and please notice, are we starting from most reactive or least reactive? So from the most reactive, it will be in this order. Give the letter of the metal that could be zinc. We said zinc is somewhere in the middle, so that is R. Give a word equation for the reaction between aluminium and hydrochloric acid. Now the question wants word, and this is the only time that you write word equation. If it doesn't mention word, that means it has to be symbol and it has to be balanced. Here he wants word. Of course, aluminium plus hydrochloric acid would give aluminium chloride plus hydrogen. A metal with acid gives hydrogen gas. Give the name of a metal that could be P. Where is P? P is the one that is less reactive than hydrogen, so you could say anything that's below hydrogen in the reactivity series. Copper, mercury, silver, gold, all of these are below hydrogen. Give a reason why the reaction of Q with dilute hydrochloric acid is not done. Well, when they put Q in water, it was very reactive, so they will probably not put it in acid because that would be a very violent reaction and it may explode. Then the question says, the diagram shows the apparatus used to demonstrate the reaction between aluminium and iron 3 oxide. And we have this equation, and the question is, state what is meant by exothermic. Remember that an exothermic reaction is a reaction that gives out heat, while an endothermic reaction is a reaction that takes in heat. Now you should remember, takes heat or gives heat to what? To the surrounding solution. So if we measure the temperature of the solution, an exothermic reaction will become hotter. Temperature goes up. an endothermic reaction will become colder, temperature goes down. So if we say what is meant by exothermic, a reaction that gives out heat. State why aluminium displaces iron. Again, if we look at the equation, the aluminium displaces the iron. That is because when we look at the reactivity series, of course, aluminium is more reactive than iron. A more reactive metal above in the reactivity series would displace anything below it because it is more reactive than a metal below it. Explain why this reaction is a redox. Now, looking at that reaction, first of all, what does redox mean? It means the reaction involves both oxidation and reduction, and you have to be specific. Where is the oxidation and where is the reduction? So the iron lost oxygen, that is reduction. The aluminium gained oxygen, that is oxidation. You have to specify each of these. The diagram represents an atom of element Z. Z is not the symbol. Give the number of the group to which element Z belongs. How do we know which group and which period? You have to remember, the group is the number of electrons in outer shell. So how many electrons in outer shell here? In the outer shell we have 2 electrons. This would be in group 2. Give the number of the period. How do I know the number of the periods? It is the number of energy levels. So how many energy levels do we have here? 3. Then it is in period 3. So remember, the number of the group is the number of electrons in outer shell. The number of the period is the number of shells or energy levels. Give the formula of the compound that forms when Z reacts with fluorine. Well, we look at Z. Z, how many electrons in its outermost shell? It has 2. That means it is something in group 2. That means when it reacts, it needs to lose 2 electrons. You should know that fluorine is a halogen. It has 7 electrons outermost shell. It needs only 1. And that means 1 atom of Z should react with 2 atoms of fluorine because it needs to give 2 electrons and each fluorine can take only 1. 1 mole of Z contains this Avogadro's number. That's what we call that number, Avogadro's number of atoms. Calculate the number of electrons in 1 mole of atoms. Well, we're told that 1 mole has this number of atoms. Now, each atom has how many electrons? Well, from that diagram, each atom has 12 electrons. So the number of electrons in 1 mole would be 12 times the Avogadro constant. A sample of element Z contains 3 isotopes. The table shows the numbers of particles in the nucleus of each isotope and percent abundance. Of course, when you're given this kind of information and you're required to calculate the relative atomic mass, then we want the abundance times mass number plus abundance times mass number and so on. How do we get mass number? Mass number is the total of protons and neutrons. So, to get the relative atomic mass of this, it is the mass number of that first one, so 12 plus 12, that's 24 times the abundance, plus the mass number of the other one, 12 plus 13 times the abundance, plus the mass number of the other one, 26 times the abundance, over 100. That gives you the relative atomic mass. Have we finished? Please check to see, are we required to put the answer in any specific number of decimal places or the specific number of significant figures? Yes. We want only 1 decimal, so I cannot leave it 24.32. I have to round it up. And please round up correctly. This is 24.3. Deduce the name of the element Z. Well, if I look at the periodic table, something that has a total of these number of electrons, so that is 12 electrons, that means atomic number is 12. Which one has atomic number 12? When you look at the periodic table, of course, the atomic number is the smaller number. So this is magnesium. Caffeine is a stimulant found in coffee, tea, and some soft drinks. The molecular formula of caffeine is this. Determine the number of atoms in one molecule. Of how many total number of atoms? Well, I have 8 carbons, 10 hydrogens, 4 nitrogens, 2 oxygens, so the total number of atoms is 24. Now calculate the MR, relative formula mass, that's the MR. MR, how do we calculate it? It's the mass number times how many atoms, plus mass number times how many atoms, and so on. So we have 8 carbons, each carbon has a mass number of 12, 10 hydrogens, each has a mass number of 1, and so on. The total is 194. Now we're told to give the empirical formula for caffeine. What does empirical formula mean? If the actual molecular formula is C8H10N4O2, the empirical formula is the simplest ratio. So how do you simplify these numbers? 8, 10, 4, 2. If you divide all through by 2, then the empirical formula is C4H5N2O. Empirical formula is the formula showing the simplest ratio between the atoms. A student uses paper chromatography in an experiment to separate the dyes in 4 different pens E, F, G, and H. The diagram shows the appearance of the paper before and after the experiment. Now, the question is, the chromatography paper is placed in a solvent. Explain why the spots on the baseline are placed above the level of the solvent. So, when we put the paper into the beaker containing the solvent, the level of the solvent must be below the baseline. This is so that the spots do not dissolve in the paper and are allowed to separate as they move up the paper. Explain which 2 felt tip pens contain the same dye. Well, looking at the final chromatography, we are looking for something that has the same dye. That means we're looking for something that has the same spots on the same height. So if you look at E and H, they have spots the same height. That means they contain the same dye. The student thought that both F and G, where is F and where is G, contained only one dye. Explain why the students can only be certain about one of them. So, which one are we sure contains only one dye? The one that went up and gave only one spot. So, G, we can be sure has one spot, so it has one dye. While F, you can't be sure of F because F remained on the baseline, and when it remains on the baseline, that means that it is not soluble in the solvent. It did not go up, it did not separate, so it might have more than one dye, but it didn't separate, so we're not sure because it is insoluble in the solvent. Remember, if a spot remains on the baseline, that means it is not soluble in the solvent. Calculate the RF value for G. How do we calculate RF values? Remember again, we get the distance moved by the spot over the distance moved by the solvent. That means we measure from the baseline to the middle of the spot divided by from the baseline to the solvent front. A teacher adds a small piece of sodium to a trough of water. Give 2 observations that are made when sodium reacts with water. Remember we said going down group 1, lithium, sodium, potassium, it becomes more reactive. So sodium, what happens if I put sodium in water? It will react, give hydrogen gas, and that means I will see bubbles of gas. And of course we said group 1 have low density, so they all float on the surface of the water. If you need another observation, you could say that the sodium solid disappears or the sodium solid becomes smaller. After the reaction has stopped, the teacher adds a few drops of phenolphthalein to the solution in the trough. Now, the solution in the trough is what? It has sodium hydroxide. You should realize that anything that has hydroxide is alkaline or a base, and that means that my phenolphthalein will turn pink. Remember, phenolphthalein is pink in a base, and this is due to the presence of hydroxide ions. Again, I'm going to remind you. If we say why is something alkaline or basic, it has hydroxide ions. Why is something acidic? It has H+ ions. Okay, this question says potassium aluminium sulfate is normally found as a hydrated salt, and we don't know how much water. When 23.7 grams of the hydrated salt is heated to remove all the water, we're left with 12.9 grams of the anhydrous salt. We want to calculate X. So if we're starting total 23.7, 12.9 is the salt, it's alone without the water. So how much is the water? The water is the rest. So the water is the 23.7 minus 12.9, that comes to 10.8. And then we work with it as an empirical formula. So divide by the mass number. The numbers that come out, divide by the smallest. This is a ratio of 1 to 12. That means that X is 12. What is the formula of ammonium carbonate? Now, I'm going to remind you again, how do we write formulas of any compound? We write the symbols and then the valency of one under the other. So, we need to know what is the valency. Remember that if we're looking at the periodic table, if it's something in the periodic table, the valency has to do with the number of the group, because it has to do with the number of electrons lost or gained in order to have a full outer shell. So anything in group 1 needs to lose 1. Anything in group 2 needs to lose 2 electrons in order to have a full outer shell. Group 3 needs to lose 3. Group 4 should share or gain 4 electrons in order to have a full outer shell. Now anything in group 5 has 5 electrons in its outermost shell. It needs 3 more to have a full outer shell, so its valency is 3. Anything in group 6 needs 2 more electrons to have a full outer shell, its valency is 2. Anything in group 7 has 7 electrons in its outer shell, so it needs 1, so its valency is 1. And then we said there are some things you cannot get from the periodic table. So hydroxide, nitrate, nitrite, ammonium, carbonate, sulfate, phosphate, all of these you have to learn their symbols and their valencies. So what do we want here? We want ammonium. Ammonium is NH4. Carbonate is CO3. And then we need to put the valency of one under the other. So ammonium is 1, so we're not going to put anything under the carbonate. But valency of carbonate is 2, so I have to put 2 under the ammonium. So this is the formula of ammonium carbonate. Remember, if you're putting a number under any of these groups, it has to be with a bracket and you put the number outside. The molecular formula C4H8 represents isomers of an alkene. Explain what is meant by the term isomers. Again, what do we mean by isomers? They're compounds having the same molecular formula but different displayed formula or different structures. So we have this is but1ene, and we're required to draw displayed formula. Remember, displayed means you show all bonds and show all atoms for 2 other isomers. So how can we draw an isomer of but-1-ene? The double bond is on one end, so I can put the double bond in the middle. That's but-2-ene, that's one isomer. And then we said, what is the third isomer? It is, instead of putting all 4 carbons in one chain, I can put 3 of them, and then the fourth is in the middle, attached to the carbon in the middle, not on the end. If you draw that as an isomer, that's wrong, because what is drawn there is exactly the same as that original one. So you don't just take the carbon and put it down at the end. It has to be in the middle of the chain. Also, you do not write as another isomer of but-1-ene, you don't write this. So instead of having double bond on one end, you put it on the other end. These are exactly the same, whether the double bond is on one end, on that side, or on this side, they are exactly the same compound. So these are not different isomers from what is drawn up there. Complete combustion of 1 mole of an alkane produces this amount of carbon dioxide and this amount of water. Calculate the values of X, Y, and Z. Of course, Y is the number of moles of the carbon dioxide. So we can get number of moles of carbon dioxide, mass over the molecular mass. That comes out to be 9, so Y should be 9. Now, Z is the number of moles of water. So number of moles of water is the mass over the molecular mass. That gives 10, so Z is 10. Now, can I use that to complete the equation? I have an alkane. Alkane means carbon and hydrogen. So if after the arrow I have 9 carbons, that means I started with 9 carbons. After the arrow I have 10 H2. That means 2 times 10. I have 20 hydrogens in my alkane. Now I can balance the equation and determine what is X. So how many oxygens do we have after the arrow? 2 times 9 is 18. Plus 10, that's 28. So this is 2 times 14. So that means X is 14, Y is 9, and Z is 10. Do you realize how we got that? Okay, in a petrol engine, incomplete combustion occurs because there is limited supply of oxygen. Complete the equation, including state symbols. So let's write state symbols first. Oxygen is what? You should realize oxygen is a gas. Carbon monoxide is a gas. Carbon is a solid. And water, of course, is a liquid. So that's L. We need to balance. So how do we balance? We have 8 carbons before the arrow. Now after the arrow, I already have 3 carbons there. So I need 5 in front of the CO. How many hydrogens do I have before the arrow? 18. That means 2 times 9 of water. And that means after the arrow, now I have 5 plus 9, that's 14. So I need before the arrow 2 times 7 of oxygen. Explain one problem for humans caused by a product of this incomplete combustion. Remember, incomplete combustion gives carbon monoxide, and carbon monoxide is toxic. And you should know why it's toxic. It's toxic because it reduces the ability of blood to transport oxygen. Remember that the blood, red blood cells are required to transport oxygen. If we have carbon monoxide, it attaches to the red blood cells instead of the oxygen. So it reduces the ability of blood, or the capacity of blood, to transport oxygen. A student investigates the reaction between magnesium and nitric acid. The student uses this method. At 40 centimeter cubed of dilute nitric acid, record the temperature, find the mass of a strip of magnesium ribbon, add the magnesium ribbon to the acid. When all magnesium has reacted, record the highest temperature, and we are required first to complete the equation. So if I'm reacting magnesium with nitric acid, what should I get? Of course, metal plus acid should give salt plus hydrogen. So here it will give what? Magnesium nitrate plus hydrogen. Remember, magnesium is in group 2. That means its valency is 2, and you need to put 2 under the nitrate, while the nitrate, we said before, its valency is 1. Is it balanced? Please do not leave a simple equation without checking that it is balanced. Well, this one is balanced as it is. The thermometer shows the highest temperature reached. Now complete the table. So the highest, we're given the highest. Reading from that thermometer, the highest is what? 32.4. Were you able to read it? So if the highest is 32.4 and the difference is 16, so what was the starting temperature? Well, the starting temperature was 16.0, so that it went up to 32.4 and the difference between them is 16.4. Do you know how that was obtained? You subtract the 32.4 minus 16.4, you get the starting temperature. Show that the heat energy change Q is about 2800. Okay, so we're trying to get Q. Q is MC delta T. What is M? We were told we have 40 centimeter cubed of dilute nitric acid. Remember, the M is the mass of the solution. So he put 40, that's 40. M is 40. The centimeter cubed is the same as the grams. Now, the delta T we already have is 16.4. So 40 times the 4.2 times 16.4, that gives you the Q in joules, and that is about 2800. The mass of magnesium used by the student was 0.12 grams. Calculate delta H. And we said, in order to calculate delta H, I need to get the number of moles. So the number of moles of magnesium is the mass over the mass number of magnesium. This is the number of moles. Now the delta H is Q over N. We already got Q previously to be this, and this is in joules, so you divide by 1000 to put it in kilojoules. Over the number of moles, this gives me a value for delta H. Have we finished? Check. The question says, first of all, give your answer to 2 significant figures. 551 is not 2 significant figures. And I have to include a sign. Now, what is the sign? We said we go back. Did the temperature go up or the temperature went down? There was a temperature rise. That means this is an exothermic reaction, and that means the delta H is a negative value. And 2 significant figures, that means it will be 550 kilojoule per mole. Explain why using a polystyrene cup instead of a glass beaker would give a more accurate result. Remember, all of these experiments in which we're measuring temperature, we should do it in a polystyrene cup. Of course, this is because polystyrene is an insulator, so there will be less loss of heat to the surroundings. The table shows the number of protons, neutrons, and electrons in 5 species. Which species is an atom? In order to be an atom, what should it be? It should have the same number of protons and electrons. Remember, to be an atom, that means it has not lost or gained any electrons. So looking at W, for example, number of protons is equal to the number of electrons, so that's an atom. Which species is an ion with a positive charge? Now, to have a positive charge, that means it has more protons than electrons. Protons are positively charged, electrons are negatively charged. If protons are more, then this would be a positively charged species. Which species is an ion with a 3 negative charge? 3 negatives means it should have 3 more electrons than protons. So if it has number of electrons are more than the protons by 3, then it has a 3 negative charge. What is meant by atomic number and what is meant by mass number? Please remember, atomic number is the number of protons. So when you look at the periodic table, it is the smaller number. That is the atomic number. It is the number of protons in the nucleus. Usually it is the same as number of electrons if the atom did not lose or gain any electrons. What is meant by mass number? Mass number is the total number of protons and neutrons in the nucleus. The diagram shows a Bunsen burner that uses methane. During combustion, methane reacts with a gas in the air. Of course, in order to burn, it has to react with oxygen. So we have either complete combustion or incomplete combustion. In both cases, we're reacting with oxygen. But if we have complete, it gives carbon dioxide and water. So the products of complete, carbon dioxide and water. Incomplete, we said this happens in limited supply of oxygen. If we don't have enough oxygen, then it gives, instead of carbon dioxide, it gives carbon monoxide and water, and sometimes it also gives carbon. During incomplete combustion of methane, carbon monoxide forms. Give a reason why carbon monoxide forms during incomplete combustion. We said it is formed during incomplete combustion due to limited supply of oxygen. If we have lots of oxygen, it will give carbon dioxide. But carbon monoxide is due to limited supply of oxygen or not enough oxygen. Now, why is carbon monoxide poisonous? Remember we said, what is the hazard of carbon monoxide? It's toxic or poisonous. Why? Because it reduces the capacity of blood to transport oxygen, or reduces the ability of the blood to transport oxygen. The equation shows the reaction between methane and bromine. Give the name of this type of reaction. Again, we said when an alkane reacts with a halogen, this is called substitution reaction. Please, if he says what's the name of the reaction, it's substitution. Sometimes we're asked, what other type of reaction is this? So basically it's substitution. But sometimes he says, okay, it is substitution. So what other kind of reaction is this? This is a reaction that requires light, and we said reactions that require light are photochemical. But originally, what is the name? It is substitution reaction. Magnesium is a mixture of magnesium atoms and aluminium atoms, and he's saying calculate the percent of magnesium atoms in the sample. So percent of the atoms, that means you're going to count the magnesium over the total times 100. So we have this is an example of alloys, and remember that we said alloys are mixtures of metals with other elements, whether metals with other metals or with other things that are not metals. And if we're required to get the percentage here, I have 3 atoms of magnesium over a total of 18 atoms times 100. That gives me the percent of magnesium in this alloy. A teacher demonstrates the reaction between sodium and water. The teacher fills a trough with water. Remember that wide beaker we call a trough. And then adds a piece of sodium. The sodium reacts with water, forming bubbles of hydrogen gas. We said sodium with water will give sodium hydroxide plus hydrogen. So you'll see bubbles of gas. And a colorless solution. State 2 other observations. Please don't write first thing bubbles of gas. He already mentioned bubbles of gas, and most students, they see what is the observation, the first thing they write bubbles of gas. Well, he already mentioned it. He wants 2 other observations. So of course we said One of them could be the fact that sodium floats. The other fact that the sodium becomes smaller, the piece of sodium metal becomes smaller or disappears. Okay, lithium, sodium, potassium react in a similar way when added to water. And the question is, state with reference to electronic configuration why these elements have similar reaction. We said everything in group 1, they do similar reactions. Anything in group 2 will be similar to each other and so on. Why is that? Remember that the reactivity or the types of chemical reactions has to do with number of electrons in outer shell. So everything in group 1 has the same number of electrons in outer shell, or we said same electron configuration. So chemical reactions depend on number of electrons in outer shell. The table shows the radius of lithium, sodium, and potassium atoms. Deduce the relationship between radius and reactivity. Well, we know that reactivity increases as I go down in group 1, and also the radius increases. So remember that lithium, sodium, potassium, reactivity increases going down, and that means as radius increases, the reactivity also increases. Chromatography is used to separate components in a mixture. This diagram shows the apparatus used. Complete the diagram by adding the missing labels. What is that line on top? Remember that the solvent goes up until it is near to the top of the chromatography paper, so that is called the solvent front. Now that paper, of course, is called chromatography paper, and what is in the beaker at the bottom there, that is the solvent. Give a reason why the baseline is drawn in pencil. Why is the baseline drawn in pencil? We said this baseline has to be drawn in pencil because the pencil does not dissolve in the solvent, so it would not go up with the spots, and that would ruin the chromatography paper. Diagram 2 shows a chromatogram produced from 4 different food colorings. Which 2 food colorings contain the same dye? Again, if I'm looking for 2 of them having the same dye, then I'm looking for 2 of them having spots the same height. So W and Y have spots the same height. Again, calculate the RF value. How do we calculate the RF value of W? It is the distance moved by the spot over the distance moved by the solvent. If we measure that from the question paper, it comes about this number. Remember, you're measuring from the baseline to the spot divided by from the baseline to the solvent front. A student uses this apparatus to find the heat energy released by combustion of liquid fuels. First of all, what is meant by the term fuel? You should remember that fuel is a flammable substance that burns in oxygen to release heat energy. In one experiment, the student uses liquid ethanol as the fuel, and the thermometer shows the temperature of the water at the start. So this is at the start. We read it and put it in. Remember, he says to the nearest 0.1. That means you must have 1 decimal place. So if this is at the start, 20.4, and we had a temperature rise of 57.2, what was the highest temperature we got? You add these two together, the highest temperature is 77.6, so that when you subtract 20.4 from it, it gives you the temperature rise. The metal can contains water of mass 150. Show by calculation that Q is approximately 36,000. We said, how do we get Q? Q is mc delta T. M is the mass of the water, 150. And we already got the temperature rise as 57.2. So multiply them with C 4.2, This comes out in joules, so this is actually 36,036 joules, so that's about 36,000. Then he says 2.3 grams of ethanol was used. Calculate delta H. So in order to calculate delta H, we said get the number of moles, mass over molecular mass, and then delta H is what? Q over N. We got Q in joules. We said we need to divide that by 1,000 in order to put it in kilojoules. Divide by the number of moles. I got 720.7. Again, is this where I stop and go on to the next question? Please check. He says, first of all, delta H must have a sign, and he wants the answer in two significant figures. First of all, what is the sign? We had a temperature rise, means the temperature went up. That means exothermic. That means delta H is a negative value. And I want that number, so that is two significant figures. So it is only 720 with a minus sign. In this experiment, the calculated delta H is less than the value given in a data book. Always, when we calculate delta H for these kinds of reactions, our answer is less than it should be. Give a possible reason for the difference. We said our numbers are usually less due to loss of heat to the surroundings or incomplete combustion of the fuel. Okay, we're going to stop here for this second part, and we still have a third part of questions and answers on the IGCSE Chemistry Edexcel according to the Modular Unit 1. Thank you for listening.